The unsaturated and saturated zones. Capillary fringe. The two primary divisions in the upper layers of the Earth are called the unsaturated and saturated zones. These two terms refer to the amount of water each zone holds in addition to the ability of that water to move. Each zone has special characteristics which make the movement of water possible or not based primarily on the amount of soil and the types of rocks found in the ground. These zones have no defined limits, their depths may vary considerably, and they are both vital for agriculture and for use as sources of fresh water for animals, plants, and people. The unsaturated zone is found in the upper level of the soil, where water may be confined in small spaces between particles of soil and rocks. Because of the greater amount of soil and rock compared to water, water has a difficult time moving through the unsaturated zone. It is more restrained and compressed than water located in the saturated zone beneath it. More solid rock, such as granite, permits water little movement, while more porous rocks and soil, such as sand and clay, allow water greater movement. Nevertheless, despite the solidity of the unsaturated zone, water can still move through it by flowing both upward and downward. Rainwater seeps through it to the saturated zone while plant root systems draw water from this zone, making it a crucial component for plant survivability. The saturated zone lies beneath the unsaturated zone, and its upper level is commonly called the water table. In the saturated zone, water flows more freely because there is less solid rock to interfere with it. The depth of the saturated zone depends upon a variety of factors, including what types of rock and soil are underneath it, the amount of rainfall the area gets, the presence of nearby rivers and lakes, and the amount of water that is consumed by humans. Layers of solid bedrock beneath the saturated zone limit its depth, while the presence of more porous rocks and soil causes it to be deeper. Heavy rainfall means that more water seeps into it and that water exists in greater concentrations. Rivers and lakes, however, tend to drain water from the saturated zone, as some geologists estimate that up to 30% of the water in some rivers comes from the saturated zone. Finally, when humans dig wells to take water from the ground, the saturated zone gets depleted of water. The area between the unsaturated and saturated zones is a narrow region termed the capillary fringe zone. In this place, which varies in thickness from a few centimeters to more than half a meter, the water in the saturated zone is drawn up by capillary action into the unsaturated zone. The distance the water moves upward depends upon the types of rocks and soil. If the rocks and soil there have large pores, only a small amount of water will be drawn up a relatively small distance. If the rocks and soil have smaller pores, however, more water will be drawn up, and it will travel a greater distance into the unsaturated zone. The reason is that capillary action works better in objects with smaller pores due to the properties of liquid surface tension, which is required for capillary action. The human usage of water from the saturated zone can have tremendous effects on the environment, as taking too much water for both agriculture and human consumption can have disastrous results. In some places, the loss of water from the saturated zone causes the subsidence of the unsaturated zone, resulting in large depressions in the land's surface. And in other cases, overconsumption can cause the disruption of agriculture. For example, one of the largest saturated zones in the United States, the Ogallala Aquifer in the Midwest, has 170,000 wells pumping 20 trillion cubic meters of water to the surface annually. The result of this extraction has been an average drop in the depth of the water table of almost 4 meters in the past few decades, and there have been extreme drops of up to 60 meters in some regions in Kansas. This has led to a decline in agriculture and an increase in the cost of pumping.